Social networks, baby. Who here does social network analysis? Raise your hand. Yeah, very nice. So did you know that, who's the lead guitarist of Queen, by the way? Brian May. Did you know that he has a PhD in astrophysics? So it turns out when he was in his last year of his PhD program, he was in the Queen band, and then Queen happened, and he's like, okay, I guess I'm doing the Queen thing now. Queen happens. And then many years later, in 2007, he went back and finished his dissertation. So he's been published in many academic journals. In addition, he does a lot of books on the Big Bang for the layman, and it's super fun to read. So the moral of the story is, in all of us, there's a creative person, and then there's the math nerd person. You should combine them both. It is your duty to combine both sides. And one reason why I love social network analysis is it's so clear why those two sides come together in data analytics. So there's the art side, because there's really fun visuals, and there's the analytics side in the statistics, which I'll show you. So these are two of my passions. So today I'm going to talk about social network analysis, specifically in the case of the organization where I work, which is the InterAmerican Development Bank. And I make what's called a citation network. And I want you to think about how you could apply this at your company. So first of all, I'm really an R nerd. And recently we did this really fun pumpkin carving event at my house, and of course I had to make R. I also may or may not have made R cupcakes at one point, which you can see in the corner here. And so I'm a super R geek, and I love this conference, by the way. So overview. First of all, I'm going to talk about what is a citation network, and then how do you actually build one yourself. We'll look at the example I use from the InterAmerican Development Bank. We'll think about how do you analyze a graph, and then we'll do a wrap-up. So first of all, what is a citation network? Basically, it's a type of social network analysis. So what is that? It basically means you have a set of actors, and you're mapping the interrelationships across all those different actors. So this is a classic example where you have people. And then you can see these little arrows across the different people that might represent friendship groups, or they could be communications. They could be some sort of management structure at an organization. But you can also replace those actors. Instead of people, you could do something like documents or papers. And a citation network often is doing just that. You basically take instead of people, you can take academic papers and map the different citations across those. It also doesn't have to be academic papers. It could be something else. So here's an example. Let's look at the citation patterns across different academic disciplines. Think about what you think is the discipline that gets the most citations, that has the largest volumes of citations. Psychology, other ideas? Medicine, other ideas? Biology. Okay, so here's the answer. This was a study done in 2008, and it turns out that the largest nodes, I don't know if you can see this, but medicine and molecular biology have the largest volume of citations. This is a study done on over 6,000 journals, connected by over 6 million citations, and then grouping them by discipline. So you can see that, for example, there are arrows between different disciplines, which might suggest that there's a lot of cross-pollination across those fields. So obviously, medicine and molecular and cell biology are very related, so they cite each other a lot. But economics doesn't look like it has very many citations with medicine. It also looks like economics has a small volume of citations relative to these fields, or physics or neuroscience. So you can also think about, well, where are there opportunities for different types of research? So why are we not combining more, probability and statistics with geosciences, for example. So you can kind of see both the interactions and the interrelationships, as well as the gaps in knowledge. Here's another example. So in this data set, in this study from 2017, you have political tweets on 3 different politically hot topics: gun control, same-sex marriage, and climate change. And then the nodes are colored by mean ideology, so liberal or conservative. So a node is a user, and a link represents a retweet to another user. So what can you get from this graph? Well, it looks like there's a lot of clustering within users of the same ideological community. So it looks like people are sharing information with those who have like views, and there aren't as many users who are sort of bridging the gap between these 2 different ideologies. So again, citation networks can apply to many different things. It doesn't have to be just academic papers. So why are citation networks useful? 1, they map the influence of ideas. You can measure the impact and the spread of knowledge. 2, they identify key actors. Who is cited the most? This is often what people first think of when they think of who's important in a network. But you can also think about who does the citing. It's just as important that academics or anyone in a particular network actually is the connector between different nodes. Because if there's no one who's bridging the gap, then there really isn't a network at all. 3, they reveal clusters as well as gaps in knowledge. So how do you actually build a citation network? Network information can be written in 2 equivalent ways. 1 is called an adjacency matrix. So this is a very basic example of a graph. So basically you have these 5 nodes, and 4 of them are connected, and the 5th is sort of floating by itself. It's called an undirected graph because there's no arrows. You just have a link or there's no link. And to record this information, you have a symmetric matrix here. It's always a square matrix. So you have 5 rows, 5 columns, because there are 5 nodes in the network. You put a 1 if there's a link between the 2 nodes, and a 0 if there's not. Notice, for example, that 2 is connected to 1. So A2 is a 1 with column A1. Likewise, A1 is a 1 with column A2. So this is a symmetric matrix. If you have a directed graph, then that just means you have arrows. So in this case, 2 cites 1, for example, but 1 is not citing 2. And in this case, you no longer have symmetry in the matrix. So I've just highlighted in red the places where it was a 1 before and now it's a 0. Because in this case, B1 is no longer citing B2, so it's a 0. So that's one way to store your network data. What do you think is going to be a problem with this format? Sparsity, yes. What if you have a really big network of, say, 1,000 nodes? You're going to have 1,000 columns and 1,000 rows, and a lot of those entries are going to be zeros. What's the point of holding in your memory all of those zeros? It's going to be eventually really hard to manipulate, and it's going to slow your machine down. So there's another way, which is called an edge list. And basically that just deletes all that 0 information and condenses your data down into 2 different columns, from and to. So in practice, do this. Don't do the other way unless you want a really simple example and you just want to see what it looks like. Because once you enter your data like this, whatever R package you're working with can easily translate it into an adjacency matrix if you want to see it. So let's say you're working with documents, such as the case I'm going to show you. In my case, I was working with PDF documents. And say you're looking for citations of a particular document number. So in this case, the document number I'm looking for is this AR dash thingy. Then for character pattern recognition, use regular expressions. Such an innocuous sounding word. Has anyone ever used regular expressions here? Yay! How many people love them? How many people hate them? How many people are like, it depends on the task? Yeah. Okay, so this is usually hit or miss. In this case, it worked beautifully and brilliantly, and I'll show you an example. The R package to use is string R. Do not try to use base R for this. I did the whole thing in base R thinking I'm an R purist and I'm going to use only base R for this, and bad idea, bad. So string R makes this so much easier. Thank you to the tidyverse. So here's an example. Let's say you have text that is the projects AR-L1281 and AR-L1302 were approved in 2018. Our task, we want to search for the project numbers. So picture this is one big, huge, long 50-page PDF document, and I just want to pick out those particular citations, right? And so here's the regular expression. You can have a look. They're not that hard to pick up. The simpler, the better. If they start to get really complicated, then maybe you want to try something something other than a regular expression. But there's lots of tutorials online, and I think they start to become kind of like a fun word puzzle. So you have the text like this, and then you just use the string R function, which is string extract all, and then voila, you get the numbers out. So imagine having a 50-page document, and that's how easy it is to get these little citations. So review, why use string R package? Well, here's a fun crossword for you, and all of the answers are string R. So for example, it is part of the Tidyverse universe. It has its own handy-dandy cheat sheet from RStudio, which you can just Google and find. It's much better than base R, all kinds of reasons. So remember to use string R for regular expressions. So here's my specific example from the InterAmerican Development Bank. The mission is to reduce poverty and inequality in Latin America and the Caribbean through financial and technical support. The bank has had over 2,000 loans to sovereign governments in the past 10 years, roughly $200 billion. Each of these loans is considered a project, and each of these has its own document. So it's basically a 50-page document that explains the why, what, how come, how are we going to do this of the project. So what is this loan citation network? It is a directed network. It is built from the loan proposals over the past 10 years. Each node represents a loan proposal or a project, and the links represent citations to another project. So you just build it in the exact same way I said. You make a loop through all these different PDF documents, and you pull out the character patterns using regular expressions, and you format them in an edge list. It's that simple. So an example would be like, this is a project approved recently, and it has, this particular paragraph, and it has in blue, that's the citation of a project. And so what's the purpose of this text? Well, it's basically showing us past accomplishments of the bank in that particular sector. It shows us a related project, and it shows the spread of ideas. So this is why it could be useful to the organization. So you go through this algorithm, or this code, which isn't that long. It's only like 300 or 400 lines, and you produce an edge list, and then you make a beautiful graph. I prefer Gephi for the graphing itself. Such as the package iGraph, they also make graphs, but you can do a lot of really cool stuff with Gephi, and it's also free. So this is an example of how the graph is actually made in Gephi. The graph format itself is a non-trivial thing. Basically, you throw your points out in the program, and they're just a random blob. But you can select a different type of visualization. In this case, it's a force atlas algorithm. Basically, what that does is it clusters nodes together that have a lot of common citations. And then it spreads nodes far away from each other if they don't share a lot of common citations. So it's basically trying to give us a visual of what are all these clusters. And then, of course, you can color it by different things. Right now, it's colored by country, but you can also color it by, say, economic sector, and voila, it's a different color. You can filter, you can change the node size. Here, the node size is relative to the size of the loan in dollars. So it's a really fun tool to use as a visual aid. So how do you analyze the graph? I would say there are 3 steps. One is visually. So you make a visual, like in Gephi. If it's a really big graph, I would recommend Gephi. You can look for clusters. You can look for isolates. You can filter by different traits. For example, in the IDB, you could filter by country or filter by department. And 2, quantitatively. So one very common way of looking at a graph is thinking about what are the central nodes. And there are basically a bunch of formulas for calculating what's the importance of different nodes in the network. For example, in the case of a citation network, you might look at, well, who's doing the most citing, who's being cited the most, and then there's all these other types of centrality measures that once you get into social network analysis, you can learn more about. All of these are available in iGraph or the StatNet packages. tidygraph was also developed in 2017, and I believe it's more of a wrapper around iGraph. 3, you can model the network statistically, and I'll give you an example of that as well. So visually, in our case, we can color by country, which is what I showed you before, or you can then see and compare the graph if it's colored by economic sector. So when we say economic sector, we mean education, health, transport, some sort of aspect of economic development. So the first thing you can kind of notice here is that it looks visually like the clusters are corresponding to the country more than they correspond to economic sector. So it kind of looks like there's a blue blob over here, which I believe is Brazil, and then there's green over here. So all the colors seem to kind of be overlapping with the clusters. Whereas in the case of economic sector, it doesn't look like the clusters are correlated very much with the colors. So that leads to one possible result, which is maybe the clusters, maybe the citations happen more at the country level rather than at the economic sector level. So that's a hypothesis we can test with a model. Mathematically, as I mentioned, you can look at the most relevant loans in the network. For example, by country, it turns out at the IDB that Haiti has the most cited loans, although Haiti has a smaller portion of the total number of loans. So Haiti's loans are, I think, around 4 or 5% of total approvals. But in fact, they're getting a lot of traction. They're getting a lot of the ideas that are happening in Haiti as far as economic development are being spread across the organization. Brazil, on the other hand, being the biggest country, does a lot of citing, but the loans aren't as relevant to a lot of the others in the network. As far as economic sector, climate change, trade and investment, energy, and transport are getting a lot of attention. So you can think about this at your organization and think, well, what are some of the different units in my company that I can sort of analyze? Is it department level? Is it a project? Is it a team composition? You can start to think about the different units you can analyze and see how relevant they are in the network. And finally, you can model the network. So in this case, we had a hypothesis, which was shared country increases the probability of a citation between projects. So if I have 2 arbitrary loans in Argentina, those loans have a higher probability of citing each other than a loan that's Argentina and Brazil. So you would model this statistically by asking, what is the probability of a link between 2 arbitrary nodes? The outcome is 1, there's a link, or 0, there's no link. What kind of model does this remind you of? I'm sorry? Like a logistic regression, right? Except there's interdependence across the nodes. So that messes up the logistic regression. And then, that it's like a really nasty time series or geospatial model where you have to model all this interdependence across all the units. And to avoid that whole problem, you do Monte Carlo Markov chain. And this model does just that. It's called exponential random graph model. It was developed by the StatNet team at the University of Washington, and they're always giving workshops about this all over the world, basically. So there's a lot of good literature on this model. And the package in R is called ERGM. So here are the results. Sorry to show you numbers. Basically, you can't include too many covariates because the MCMC doesn't like too many. So it's very delicate, and it takes a long time to run. But just focus for a second on the final 2. So we can see that if 2 nodes have the same country, then there's a positive effect on the probability of a link, and it's significant. In the same way, if 2 countries have the same division or the same economic sector, then again, there's a positive impact on the probability of a link. But you can see the shared country effect is stronger than the shared division effect. So you interpret it in the same way as a logistic regression. You can calculate the probabilities like so, and then you can compare the probabilities, and it turns out it's around four times more likely that countries with the same, that projects with the same country share a link than projects with the same division. Why would this be interesting to an organization like the IDB? Because it's showing you that maybe there's country-level silos of information where projects within the same country are really the ideas are being shared very frequently. But when there's a sector across countries, you're not really sharing that information. So as a wrap-up, think about how you can create a citation network at your company. You could do so through emails, through documents. Maybe there's some sort of project level information you can use. There's also team composition level. If you need to use character pattern recognition, use regular expressions. What's the R package? String R. And finally, analyze the network with R using iGraph and StatNet. Visualize with Gephi. And then you can test hypotheses with statistical models such as an ergom. Thank you very much.